Welcome to Science with Mr. Weber. Today we'll be looking at the reactions of acids. So just a reminder, acids are molecules that are capable of donating a proton or a H plus ion. Okay, so acids and digestion. Hydrochloric acid in your stomach provides the acidic environment that's necessary for enzymes like pepsin to break down proteins. Okay, the hydrochloric acid also kills most of the harmful bacteria that you might have in your food. Okay, it doesn't kill all of it though, so there are types of bacteria like salmonella that will still survive in that environment. Okay, acid-base reactions. So remember, acids are proton donors and bases are proton acceptors. Okay, so when they react, they produce a salt and water. Okay, so this type of reaction, we call it a neutralization reaction. Okay, so we've got our acid here. Okay, we're reacting that with our base. So now your acid's going to have a pH that is less than 7. Your base is going to have a pH that is greater than 7. Okay, now they're going to react to produce a salt that is neutral. Okay, that's what we call it, a neutralization reaction. So your pH is going to be closer to 7, okay, which is neutral, and you're also going to have water being produced. Okay, so acid plus base produces salt and water. Acids and metals react to produce salt and hydrogen gas. So if we have a look at our diagram here, we can see we've got our piece of metal. Okay, magnesium, and it's sitting inside a dilute acid, so let's use hydrochloric acid again. Okay, so now the way that this will look when we write out the reaction is going to be hydrochloric acid, aqueous, because it's dissolved in water, reacts with magnesium, that's a solid, and that's going to produce salt. So the salt's going to be made up of the metal, and we're going to have the other part of our acid that isn't the hydrogen. And now it's going to be Cl2 because the charge on chloride ions is -1 and the charge on magnesium is 2+, which means that we're going to need 2 times the amount of chloride for every 1 magnesium. So we've got MgCl2 plus hydrogen gas. That's going to be H2 gas because it's diatomic. It exists in pairs naturally. So we've got our HCl plus magnesium becomes MgCl2 plus H2. Now, just to make sure that we get the numbers correct, we're going to balance the equation, and we're going to do that just by adding a 2 to the front of the HCl. So what that means is we've got 2 H's, so we've got 2 on the left and we've got 2 on the right. Okay, we've got 2 Cl's on the left, we've got 2 Cl's on the right. Okay, we've got 1 magnesium on the left, 1 magnesium on the right. So we've balanced our equation, and that's what that's going to look like. So when you add magnesium to acid, you are going to see bubbling occurring. Those bubbles are hydrogen gas, and you can test that using the pop test. So you place a lit match over the top of the test tube, and you'll hear a sort of pop or squeak sound, and that will tell you that that was hydrogen gas. All right, and finally, acids react with carbonates to produce salt, water, and carbon dioxide gas. Now, carbonates are compounds that contain the CO3 polyatomic ion. Okay, so let's have a look at our example in the picture here. So we've got marble chips. Okay, so marble chips are typically calcium carbonate. Okay, so that's solid because it's not dissolved. Okay, we're reacting with our acid. Let's stick with hydrochloric acid, aqueous. And those two are reacting to produce our salt. So our salt is going to be, so this calcium here, Okay, it's going to be Ca. We're going to take the chloride again, Cl, and again, calcium is 2 plus, Cl is 1 minus, so it's going to be CaCl2. Okay, and so that's our salt. We're going to have water, and we're going to have carbon dioxide gas being produced. Okay, so if we have a quick look, alright, just count up everything, and we'll see that it isn't balanced yet because we've got the 2 chlorides on the right and we've only got 1 on the left, so we're going to multiply that whole thing by 2, which also gives us the extra hydrogen that we needed. Good. Okay, so that's our balance equation. So that's what we end up producing. If we look over here, we can see bubbling. Okay, those bubbles are carbon dioxide gas. Okay, and the ways that we can test for the presence of carbon dioxide gas are you can take a lit match. Okay, you can place it inside the test tube, and what you'll see happen is it'll actually go out. Okay, because carbon dioxide will restrict how well things can burn, so you're going to see that match go out. But just to make sure, an even better way of testing for that is by using a solution here known as lime water. Okay, so lime water is a solution of calcium hydroxide. Okay, and what happens is, let me just drop this equation really quickly. So if we have carbon dioxide gas being bubbled through, okay, we're going to see, so CO2 gas plus calcium hydroxide, that's OH2, because the whole thing there has a 1 minus charge and Ca is 2 plus, like before. Okay, so we're going to react these two to produce calcium carbonate, which is ironically what we started with. And that's going to be solid. And it's also going to produce water. So let's have a quick look if that's balanced. Yeah, that looks like it is. Good. So water there is liquid. And that's aqueous. Alright, so what you'll see happen is, so calcium hydroxide is a clear liquid. So it's going to go from being clear, and then once you react it with carbon dioxide, you get this calcium carbonate solid being produced. This is white. And so you see it go a milky white color inside that test tube there if you're running carbon dioxide through the tubing there. Okay, and that's a really clear indicator that you've got carbon dioxide gas present. Okay guys, that's it for acid reactions that you need to know. Thanks for watching. I'll see you next time.